Well, welcome to the collaboration breakfast. These are some of our amazing ambassadors. There's more of them in the audience. My name is Lehn. I'm the community director here at RISC-V International, and today we just wanted to ask some of our experts some questions. So I'll start them off. I'll let them each introduce themselves and what it means to them to be a part of the ambassador program. Where to start?
Yeah, good morning, everyone. I hope you enjoy the coffee. Make sure you get some more bread, because that will be an amazing morning. My name is Flo. I'm the ambassador of RISC-V, one of the first ambassadors. Really happy about that. I'm working for OpenHW Foundation. OpenHW Foundation is doing open source RISC-V course, so I'm really happy because I still can work on what I love. What it means for me to be an ambassador: I have the chance to come to events like this and talk with all of you about RISC-V and how we bring more RISC-V into more diverse applications. We are pretty good in AI. We still can put more inside. We are coming to HPC. We're also going for automotive. So I'm really happy to be there and talk with people and promote RISC-V and show different possibilities where we can bring more in.
Cool. Good morning. I'm Carl. I'm an individual member and an ambassador. I came on board to be an ambassador for a lot of the same reasons Flo did. It's to get the word out and help people adopt and use RISC-V and help build the ecosystem in the community. And that's one of the reasons why I enjoy being an ambassador, is that it gives me the opportunity to go have both on and off the conversation records with people who don't want people to know they're using RISC-V, but it's still important to know what they're doing and why they're doing it.
So good morning, my name's Nick. I'm from the University of Edinburgh. So I'm an academic. I'm also an HPC guy. I chair the HPC SIG. And what we realized for the HPC community is really a key bit to get RISC-V accepted was to run community events. So we started running workshops at some of our biggest conferences. And actually the bit that's excited me the most is community members have taken on some of these other workshops. So it's sort of snowballed, and it's not just on one person, but actually we've really been able to leverage the community. And for me, being a RISC-V ambassador, it is all about community. I was actually thinking yesterday, I go to lots of conferences around lots of different topics, and I can honestly say I think this is the friendliest community that there is, and it seems that we've got a sense of purpose. It always seems like there's people happy to have a conversation, and I think the ambassador program is a bit of that helps set the tone, and obviously all the great work that Laurie and her team do.
I'm Jeffro. I think I know probably half the people in this room. I've been involved with RISC-V since RISC-V Foundation moved over to the Linux Foundation, and worked together with Callista to build the current organization before I picked up my bags and moved over to Red Hat. I'm very pleased to be an ambassador. Megan and I kind of started started the ambassador program in I think 2020, and I'm amazed to see how many ambassadors there are and how much good work they're doing out in the world. I like to be an ambassador because I really like to spread the word about this fantastic community. It's been very good to me, and I think it's changing the world.
Changing the world, totally. Yeah. All right, so I'm going to ask a list of questions. You can just go ahead and pick up wherever you would like to answer. So for everyone, what are the highest priority areas as of 2025 that we need to address for RISC-V adoption?
Should I go first?
Go for it.
Thank you. I will get shoot. So RISC-V, I love it, and we have a broad adoption. What I personally think we need to get more into general purpose computing, and to do this, we need to have standards. So we have a lot of requirements, specifications, but we need to bring profiles like the RVA23, and we need to finish this and also offer a kind of certification program, which is underway, which a lot of volunteers work on, so that is great. I personally hope, and it's a little selfish and I'm not really contributing to it, so I have to apologize, But I really hope that we can have the certification program up and running as soon as possible. It allows us to make chips based on the profile, on the certify them, and then give it to all the cool software guys. So Red Hat is already doing a lot of stuff, but we need much, much more of them. We need every one of them. We need to have the ecosystem for software ready on RISC-V to push it in the general purpose compute domain. And I really hope that in the coming year, we're making big advances in this.
Yeah. For me, I think we're doing a great job. You know, the tagline we had on Summit last year of RISC-V is everywhere is absolutely true, but most people don't recognize that it is. And I think a lot of what needs to happen is we just need to. It's also a chicken and the egg problem. Like the way I've described it is that all of the member companies are standing around the pool going, "Man, that looks great," but I don't want to be the first one to jump in. And so it's trying to do interesting things on the periphery to get people interested, which is a lot of what I'm doing, so that we can say, hey, look, this works. All the things you want to do function. Doing a lot of the behind the scenes nitty gritty stuff, porting thousands of packages, making sure everything functions, so that when someone does decide to go stand up on that diving board and make the leap, we're already ready to applaud them, and they can go from there.
In terms of a RISC-V specific thing, I think from the HPC angle, we see vendors like NVIDIA and AMD just putting vast resources into the software ecosystem, way beyond the capability of a single company, you know, within this sphere. But I think we've got a real opportunity to pool our resources around things like the accelerators and the software story. I'm thinking specifically about HPC, but I'm sure it applies to other areas as well. Because, I mean, it's a bit of a trite comment, but it's time and time again we hear when one person wins, everybody wins. And I think, you know, I think that is true. I think the community really does give us that opportunity to join forces to challenge some of these other big investments that are being made by single companies.
I would say that the most important thing to focus on has got to be high-performance hardware availability.
Yeah.
And I'm speaking very selfishly from somebody working inside Red Hat to, you know, make RISC-V a supported platform in Fedora and to kind of move it through the system, because it's enterprise software is very different from a normal distro.
Yeah.
The real stumbling block that I have seen is build hardware, and this is also coming from my experience with Rise Project. We need to be able to build stuff, and in order to build stuff, we need higher performance hardware, and it needs to be in a format that we can consume, meaning it needs to be able to put into a lights out data center and operated remotely. It needs to be able to power cycle. We need to get stats over a BMC, and there's just a certain set of requirements that I'm pleased to see, many of which have made it into the platform spec. Yep. So I think we're on our way. It just takes time to get there.
Yep. Building hardware is hard.
It definitely is.
Teamwork makes the dream work, right? So there's a lot of work going into the matrix extension standards at the moment. Which one or ones of these are most important for your specific workloads?
Ooh. Nope.
I think for us in HPC, the elephant sometimes in the room is the precision. It's really difficult to get people to move away from FP64. It's not necessarily that they need it, but it gives them a warm, fuzzy feeling. So I suppose the lazy answer to me is whichever standard can give us that the easiest, most easily.
So you're saying you want to go to FP128?
Well, some people would like that. There is actually an argument for some people want that. But yeah, I think for us personally in HPC, there's two sides. What the hardware will give us, but also moving people away to some of these lower precision things to accept these different standards that are coming out.
I think for me the big one is vector and SIMD in general, because that's how we win. Being able to get to a point where the amount of data that you can move through the processor is just exponential to the number of instructions that you're executing is huge. That's where we go from the performance level where we are today to being someone that large enterprises are going to be like, we should just do that. Like the other vendors that we're working with don't have anything like this. And once we hit that, that's when it takes off like a rocket ship. So for me, that's the big one.
I don't really have an opinion. You mentioned the DSP extension, so I'm a really big fan of this, especially for microcontroller units or so. I think it gets a lot of stuff done, and the overhead is relatively easy. But yeah, if we go to HPC, the vector extension and that paired with a matrix multiplication engine is very powerful, and that's also what we see from the workloads coming. At OpenHW, for example, we are prepared for this. We have a X interface specification, which lets you add custom accelerators and something like this. So I hope the specification of the instruction is finished, and then it would be rather easy to drop it in. I'm personally more the MCU guy, but you mentioned DSP, so I personally love this because it gets with low power envelope a lot of stuff done. But HPC, we definitely need to have the matrix and also very powerful vector processors.
Yeah.
I think I'm with Flo. I don't necessarily have an opinion about a specific extension. In my mind, a lot of the important work is gathering these extensions together and making them all work together. And so that takes me straight back to the profiles and platforms group.
First time Flo doesn't have an opinion. All right. Are there other symbiotic technologies that strengthen the RISC-V ecosystem?
Open source software, like it's got to be. We leverage so much of it. We contribute so much of it back. It is the key to what makes all of this successful. Is just sitting on the back of the incredible corpus of software that people have poured their passion into for years just to make computing better. And then being able to take that and go leaps and bounds forward than anyone who's been trying to do these sorts of things in the past. Like, I have a lot of respect for the folks at DEC for doing Alpha, and a lot of respect for the folks at Sun when they did Spark, and a lot of respect for the folks who did MIPS. But the thing that held them all back was you had to then go find people to make the compilers. And that was always the sticking point was, oh no, this compiler doesn't support C89. What are we going to do? And then we got to spend millions of dollars to do it. And now we have amazing things like GCC and LLVM. There was a talk at VCF Midwest this past week. Someone ported LLVM to the 6502. They literally booted Linux on a Commodore 64 because they could. Like, it's that kind of passion and availability that is going to make stuff that we can do with RISC-V just incredibly amazing.
I think Carl has stolen. Well, stole the word because I'm about to steal exactly what you just said. So no, I'm blaming you for that. Yeah, open source software, and specifically in my mind, compilers.
Yeah.
The fact that we look at a lot of these vendors and they're using things like MLIR, LLVM, all of this, and you think how much extra work it would be if we didn't have this great tooling and this knowledge in the community, and also how much overlap there is. I just find it fascinating that there's the open source software side, and then we've got the open hardware in RISC-V, and actually then we've got these meeting points, and it feels like a lovely connection between them, and something really special going on at the moment.
One of the other things that I will say that I'm really looking forward to start to see is that I don't want RISC to become RISC in name. I don't want RISC-V to become RISC in name only, like a lot of the processors that we have out there that people immediately associate with RISC. And then I go, well, wait a minute, they have an instruction that tells you whether this floating point number is 0 or null in JavaScript. Like, that's not reduced instruction set computing. And so for me, it is the software that's going to come out that's going to provide the optimization layers so that we can keep the software simple and still take advantage of it from a simplified programming perspective. So a lot of the stuff that you're doing within the HPC space, things like OpenBlast and FFTW and all of those things, where you can have one simple, common, open API, it understands the differences in the hardware and then can just act as a rocket ship to just make your code faster by literally linking it in. Like, that's going to be huge.
One thing I just want to very briefly add, Flo might say this, but it's about Open Hardware Group. The reason I think Open Hardware Group is so exciting is there's almost this pipeline from open source software through open standards to open source hardware through the Open Hardware Group. And it just feels like there's that lovely sort of connection through all these things. Maybe you were going to say, blow your own trumpet. I wasn't sure, so that's why I wanted to say that.
I just think we need an ambassador program at the Open Hardware, and you're the first one.
Yeah.
Jeffro, I need your help to set it up.
Call me. So there's no way I could build on this. I will say that open source software and a software ecosystem is the most important thing to foster this growing movement. And to that, I'm going to put a call out or a shout out to RISE. RISE project has been involved now for 2.5 years in trying to augment the existing system. And as I said the other day, the state of software is fantastic, and there has been a ton of software that has been developed by individuals, but it's unevenly distributed. And in order to bring it up to a commercial standard, which will essentially launch RISC-V into the stratosphere, we need to band together and do all the work. So,
Yeah, I just want to add on Nick, but also what you said, Jeffro and Carl. I really think the software is very important, and I love what is happening in RISE. I love what is happening, like we are working more closely with the Octo project, but there is actually so much more thing going on, and it's RISC-V as an open standard where you all can do your own stuff, but now we are working together and do more together. For example, in the OpenHW group, we thought we are making RISC-V cores and let's make them industrial grade, and then people put them in the projects. But then people start showing up. Do you have compiler support for this? It should be mostly off the shelf. No, that's not working. And then the amazing thing happened. These people joined OpenHW and made the compiler support for GCC, LLVM. And then we have now Red Hat, for example, as a member, and we're working together on Linux systems. And we are making an OpenHW system where you can run and boot Linux on a cloud platform who is supporting FPGAs, not naming any names. But this collaboration in software and how we now closely work between hardware and software is really mind-blowing. And I do think we have to intensify it. We even have to do more of it. So we are absolutely in the right direction, but yes, software is the single most important thing. And that comes back to our first question, actually. We need more hardware to enable our friends from the software. Give a hardware to the RISE project, they will kiss you. Right, Jeffro?
I'm not going to personally sign on for that. But yes, there will be kissing.
Yeah.
One thing I did want to add too is that I was talking about this with somebody at Red Hat a couple of weeks ago, and I said, they were asking me why we were members of the Open Hardware Group, and I said because there's for one thing, it's emboldening the entire system to explore what open hardware looks like and how that could actually benefit some of these companies that are doing everything in a closed and proprietary way. But the lights really came on when I said, and picture making an entire computing system that is open all the way down to the transistors, because that's possible now. And yeah.
It happened already.
Yeah.
There is the folks from ETH Zurich. They made a chip. I saw it this summer in the RISC-V Summit in Europe. We should have invited them here. We forgot that. Oh, well, they are busy. But they made a chip. It runs Linux, and I was playing Tetris on it, so that's absolutely
Very
legit.
advanced.
But the chip is made from open source cores. The very later was used, so the synthesis was open source. The layout was open source. They used an open PDK, which is open source. So the whole chip down to the transistor level is actually open source. And that's also an amazing thing. I believe we are, with the RISC-V, enabling this open source revolution in hardware and making possible that also, like Carl, next year you're making a chip and maybe we start with an MCU, but then in 2-3 years we have a Linux system.
That's what I want to do.
Nick, we also need an HPC.
I don't know if we're going to be able to find cheap FPGAs that we can do like HPC work on for, less than $30, but we'll try.
Thousands of CVA6s working hard.
There we go.
Creativity, I like it. What's the hardware you're most excited to see in the coming year?
I think we kind of answered that in the last one. Like, it's not a problem. Like, but it was more just to riff on what Flo was, he stole my thunder. Like, that is what I'm most excited about, is next year. It's okay. Starting with a cheap FPGA, building a simple microcontroller on it with trace and debug, so that when you bring it up, people can go get hardware now. But it's also entirely open, so you can be like, this doesn't do exactly what I need, and all of the bits and pieces are there for someone to pick that up, make changes, and then I'm excited to see where that evolves into. Like, me doing the initial work of like, here's how I got it all working, and if you just want to go download the bitstream and load it on this cheap FPGA and get a microcontroller up, great. But then to watch people go do whatever they're going to do with it, like TensTorrent's demo where they have added vectorization to Doom to make it run faster. Like, that's awesome. I can't wait to see people do fun stuff like that. I can't wait to see people take this cheap little microcontroller and do something crazy, like use the vector stuff on it to be able to do video decoding onto an HDMI output entirely in open source, running at like 12 megahertz. Like, that's going to be awesome. I can't wait to see it.
I have nothing to add. You definitely got it.
Megan just asked me if I maybe could say something. She said, Flo, you always have to say something. Anyway, hardware which I'm really excited about. We had like the Shanti team 6-7 years ago who made the C910. We heard about it yesterday. That enabled and brought the first hardware, and we are greatly benefiting from this. There are a lot of other things inside. Like yesterday I talked to Professor David Harris from the Harvey Mudd College. He's making an open core which can run Linux, and he's working on making that available, bringing it in industrial use. So hardware in general, I'm a hardware guy. I'm absolutely fascinated about hardware and what is coming out, buying the sports and then doing cool things like using vectorization for Doom.
Yeah.
That was long overdue.
It's funny because that can be a joke, but then 5 years from now, that could be running a space system or an avionics system.
Yeah.
You know, it's innovation by iteration.
And I definitely, if you are interested in it, definitely go talk to the TensTorrents folks, because they did some really interesting stuff. Like, one of the things that I was like, oh, that's clever. They loaded the entire palette for the game. It's only 256 colors, so it's pretty easy to do, into the vector model. And instead of doing an index lookup to find the colors, they did it all with scatter gather in vector in order to make it go faster. It was significantly faster than doing the index lookup on their really slow core. And not slow because of anything they did other than running on a giant FPGA. Like, that thing is clocking at 15 megahertz, and it plays better than the 25 megahertz 386 that I first played Doom on. It's incredible.
I just want to add something quickly. Jeffro, you mentioned space. I completely overlooked this. We did some microcontroller unit in the open hardware, and we put everything together, and it was kind of cool. But then came a university from Canada, University of Saskatchewan, and they said, hey, we want to go to space and we do some radiation hard testing. Can we use your design? Well, yeah, sure, why not? So actually we have on our table a board, and hey, surprise, it has a blinking LED, so it works. But this board is actually now, we had ion testing and a lot of stuff, and it will go to space, and that is a fully open source chip. The tape out was done by Global Foundries, big shout out there. So it's not completely open source, but the RTL, everything is open source. And that is going to space. And that's the amazing thing. And that was not what we intended first, but that what kind of enabled it. And that is the great thing I like in this ecosystem, the hardware, like Doom in the vector. A thing which was just a microcontroller suddenly being in space, Red Hat testing the software on us.
Yeah.
It's mind-blowing, and this accelerating is really awesome.
Yeah. And we've been saying this for 2 years, but I'm going to keep saying it. Like, I'm really excited for RVA23 hardware, like, especially to help with the build farm problem. I know you need a big 64 core, 4 gigs of RAM, as was talked about in the keynote yesterday, to do things. But Len, you've got weirdos like me who are going to go get a whole bunch of small SBCs, networking them all together, and it's like, look, it has lights out management and it's 64 cores. Yeah, it's 12 boards, but like, it gets the job done with a little bit of DISC-CC and a little bit of CC cache. We might actually be able to get a lot of interesting things built in a short amount of time, and I'm excited for that too.
So something we've been talking about a lot in terms of the new hardware is the CPUs. I think for me personally, what's really exciting are the accelerator cards and the PCI accelerator things. I mean, going on the show floor and you can see all these vendors, a lot of which you can put your money down and get it next week, taking all their own individual views and opinions on things, and I can just shove it in an existing system and get going with it. For me, that's hugely exciting, and that's really where RISC-V is serving this greater goal, if you like, of we want to do machine learning 10 times faster. We want to do this workload more energy efficient. So for me, I think that's very, very cool.
Yeah. What parts of the software ecosystem do you feel, I sort of went over this, but do you feel are the most in need of help with RISC-V enablement?
I think the two big ones are the stuff that we've talked about, and that would be the compilers. There's a lot of great work there. There's a lot of great work that needs to be done. I am less scared of contributing to LLVM than I was 2 months ago. So if you want, come find me. I'm in the developer zone. I will share with you the link to the YouTube video about that LLVM talk from VCF, mainly because it made it really, it was a great job of explaining how LLVM works, which makes it a lot less intimidating to contribute to. But the other one is the kernel upstream patches. Like we need more folks to look at that stuff, to test it, to give feedback. There's a tremendous amount of things there, so it's a great place to jump in and look at things. Just, there are some interesting personalities in that group, so just be aware and gentle, and it'll all be fine.
So for me, I mean, we've talked about open source software, but there's a lot of closed source software, especially in some domains. I'm thinking about certain HPC packages where it really is a bit of a challenge to make the commercial case to the company to port over to RISC-V. It's easy to GitHub clone something and build it and play with it as an enthusiast, but to actually say to a company, you need to invest effort, here is the commercial payoff for that. I think that's a challenge, and that's where we need to get a wider story together. And potentially goes back to the hardware availability. If you've got the hardware and they can see how people would use it, and they've got that there, then I think that's a more compelling story for them.
It's very much a chicken and the egg, and that's why I do the weird things that I do, is to try and make it more interesting to folks. Be like, oh, we can prove that this works with stuff that has now, and then it's worth making the commercial investment to try and make things better. But it's also why I'm, I talked in the marketing meeting a couple days ago, asking all of the various member corporations of like, what is the software that your customers are trying to run? Because we don't necessarily know. So that we can then start engaging with those communities and having the conversations of how do we make this better on RISC-V? How do we make whatever their end users need? RISE is doing great work, and I don't want to discourage that at all. But it's one of those things of like, there's multiple levels of abstraction between what RISE is doing and what customer workloads are. So like, come talk to us. Like, we want to know where you're running into problems. And right now, the conversation is mostly dominated by, man, we need CUDA. Oh, it's going to take so long to get CUDA. And I'm like, there's so many alternatives to CUDA that are open that we can use right now. And let's see if we can make that better and make that a better experience on RISC-V.
But you also need to be a pragmatic.
Oh, for sure.
And there's a lot of code using that.
Yes.
So it really helps people porting the codes over. I mean, I couldn't agree more. It'd be great to have an open standard that replaces it, but
complements
that's a challenge in and of itself.
Not replaces it, just complements it.
I would add that there are some fundamental things that are still in need of work. UEFI and ACPI are not universally distributed among hardware at all. It's the ecosystem, like many new architectures, is very dependent on device tree. Yep. And I think that, I know there is work being done on that. There's being work done in RISE in the firmware working group. But I would say that's possibly one of the most important ones in my mind.
Yeah. It is. It's also, it's so hard. Like, the conversation I was having with Redbeard yesterday is like, there's 100 people in the world who understand EDK2, and 125 of them work for AMI, and they're never going to care about RISC-V until somebody shows up and like, here's a $500 million. So trying to figure out how we're going to make that better, or support projects that are trying to be a more accessible code base than EDK2 to solve the same problem will be huge.
Amen.
And Flo has no comment. I'm making a tally over here. What are some gatherings that you would like to see with RISC-V presence next year?
This was my question, so I want to know what people's answers is for this.
So the presence?
Like, where would you like to see more of a RISC-V presence in other events?
I see. Oh, in other events.
Yeah.
Ooh, okay. I would like to see a corner of embedded world dedicated to RISC-V.
That would be awesome. Embedded world.
Embedded world.
Big corner of embedded world.
Yes.
I'm also curious, like, anyone in the audience who has something that, like,
Yeah, absolutely.
We'd love to know.
I will walk this microphone over to anybody who has an opinion.
Or you can just shout it out. Or you can come talk to us
just
later
yell.
if you don't want to be on the microphone. That's fine too. We're friendly. That's why we're ambassadors.
Oh, I'm coming,
Oh,
Yuning.
Uni's got one.
But hey, we need 5 minutes max.
No, I just need 5 seconds. So I'm gonna ask very last questions. When can you start using RISC-V for daily life?
I mean, some of us are.
Yeah. When can you start? And what kind of level you guys want it to start using it? Right.
Yep.
Price point, performance, whatever.
A lot of it is just trying to find the workloads that match the hardware. So I was super excited. I gave a talk at Texas Linux Fest 2 weeks ago, and I gave the talk on a RISC-V laptop. Your RISC-V laptop, in fact, and that was awesome. Like, I had a lot of nerd cred of doing cat CPU info before my talk, and then opening up my slides and giving the talk, and everybody was like, "Wait, you can do all of this with RISC-V now?" And I'm like, "Yeah." So it's just a matter of, like, much like 1997 was the year of Linux on the desktop, and it has been every year since. 2025 is the year of RISC-V on the desktop, and it will be every year since.
So we can stop banning people coming to the summit not using RISC-V last year. Right, let's do that, right? Next year, we're going to have a 16-core RVA23 upstream kernel with all the distro. If they don't use it, ban them. Right? Or, pay for the ticket, we give the hardware for free.
We will miss all the executives who need PowerPoint because no one ported PowerPoint so far.
I did get PowerPoint working on RISC-V.
Oh, maybe we can talk. I need some support.
Yeah.
One more question here, please.
So RISC-V came out of university, came out of the education space. I'm particularly interested in giving back in education, STEM education. And when I hear industry working a lot on tough problems, I think maybe the RISC-V Foundation or some of the organizations or ambassadors could be requiring or strongly suggesting, I don't know what the right requirement is, but getting the collaboration back to the universities, and how can we get all this development of all this hard software when people work their day jobs and their day job doesn't require them to do that, it's hard to do. But university students, undergrads, grad students, postdocs, those are boundless resources, and you just give them money and ideas, and you don't require them to do specific tasks. And I think there could be just more, if you drive more back into the education space, like you said, ETH0, all that stuff, this open cores is going to, I think, really take off, and you tie it all the way up to the AI stacks that have to run on top of it. All the research in between, the whole vertical stack.
For sure. I'm going to plug Megan's Academia and SIG meeting, which next week or the week after? Week after. It's on Thursday. You do not have to be a RISC. Do you have to be a RISC-V member? You have to be a RISC-V member to attend, but come talk to us. We would love to engage with you. One of the things that I'm trying to work on next year is I'm engaging with a couple of the local universities in my area, and we're going to try and bring RISC-V stuff to Major League Hacking. So as they're doing the big hackathon things, we're going to try and have some simple things that folks can work on over a weekend and just be like, here's the pieces you need to get started. Here's some suggestions of things to do. I can't wait to see what you have for us in 3 days.
So, as an academic with students doing RISC-V, I couldn't agree more. And actually, we don't need much from industry. What we need is an interesting problem that you think is interesting, and a way of feeding that back.
Yep.
And actually, certain companies like TensTorrent, when they've got open source software stack, it makes it so easy for a student just to go in and hack around with it. We don't need to worry about NDAs. We don't need to worry about getting access to code.
Yep.
And actually, I'd hope that they get some benefit out of it as well.
Yeah.
So I personally think that open way of working really is a massive help there, because I couldn't agree more. And we are desperate for interesting student projects. So if you've got some in industry, please let us know.
Yeah.
We have one more question here, and could I add
Yeah, I just wanted to
something
follow
that?
up on that. If you do have fun projects for students, please reach out to me, because we would love to get these into their hands. We last year hosted 2 in-person hackathons. We did one online because we're really seeing that our base is around the world. So trying to figure out how to get these hands-on experiences and tooling into the hands of these people, right? Because I think especially students, they have time, creativity, and the space to do it. So trying to figure out how to get the information to them. So if you have universities that aren't using RISC-V or have interest in RISC-V, they can reach out to us. We'd love to welcome them into, the academic and training SIG, and make sure they have resources they need, projects, right, that the professors don't necessarily have to do. Carl and I have been talking about a hackathon in a box. So something that we can send to them and then they can do in their classroom, with not necessarily them having to have the full knowledge, but they can all learn together. So definitely a goal of ours is to support the students from ground up in order to expand in RISC-V.
And I want to be clear, a large portion of that box is stickers.
I will also throw out a call to the existing course material that's available through Linux Foundation.
Yes.
A lot of that is free, and a lot of that can really help bootstrap some of these students, particularly if it's very hard to show up in a classroom knowing nothing and be handed, a chip and a soldering iron and be pointed at software that you don't understand.
Yeah.
So bootstrapping through some of the free courseware out there is a great idea.
So I wanted to add something quickly to this. I fully agree. From my point of view, actually, there are a few steps. So the first step is really the courses at RISC-V.org, where you can get all this basic knowledge. That's a great resource. Then making the hackathons. What I also saw, because in the open hardware, we have this mix. We have academic members. We have also the industrial members. And what I really like to see is that there are so many projects in RISC-V, not only in open hardware, like we have the Beijing Institute of Open Source, who is doing an amazing open source chip, which is also free to check. And it's done by students from Dr. Bau with the team. But there is also like the CV Volley, where some people are here, is from Harvey Mudd. They do an open source chip. But actually, the integration between these people and the industry is already happening. But I fully agree, we need to find a way to make this even more, to tell the universities, look, if you do some research, you can get it in real hardware. Like the Beijing Institute of Open Source, their core is in real server hardware already starting, and that's amazing. But also like some of our cores, yesterday Accelera said, they have one of our cores in their accelerator and you can touch the hardware on their booth. So that is ongoing, and this collaboration, I fully agree, we need to find a way to make this even more intense and show the universities, hey, you really can do your research on this real hardware, or you can collaborate and industrial people will use it. And then you also can get sponsorship from this from industrial. That's the next step where we need to say, hey, support them. Don't be only happy, also show some love.
I gave a guest lecture at a university last week and talking about RISC-V. And probably the thing that got them most excited is that at the end, the TA was like, are there jobs for doing this in RISC-V? And I was like, go to risc5.org, click on members. Every single one of them is looking for people who are trying to do silicon validation, RTL, all of the things that you're all excited about. They're hiring right now. And everybody got real excited about that. So I think a lot of it is just people don't know. And so we just got to get the word out. And that's kind of what we're trying to do. So, Mike, what do you got?
So, hi, Carl. So, I see so many familiar faces in here, and I just want to thank Google for sponsoring this. Much like you, guys up there, and some familiar faces here. I'm an early adopter of RISC-V. There's only one thing alone keeping me from using my RISC-V laptop as my daily driver. I need Google Chrome. I need Google Chrome.
Agreed.
Chromium doesn't cut it. I need Chrome for my corporate email, for my calendar, for DRM when I go to YouTube, for all of that. I hope someone can please, please, please accelerate that. That's all. Thanks.
Cool.
Chrome on RISC-V. Oh, and thank you, Google, for sponsoring the breakfast. That's awesome.
Yes, thank you, Google.
Hi, I'm really excited you mentioned compiler not just once, but multiple times. I work on LVN, so I'm going to ask a daring question.
Thank you so much for your work.
Thank you. And my colleagues and all the community. And by the way, LVN developer meeting is next week.
Yep.
So the daring question is, what do you need? Because sorry, just a little bit context. Because we work on LVN as our day job, and most of them we can work on LVN blindfolded. But I'm a little bit worried about. I'm not so sure, but I'm worried about we miss some picture. So that's why I asked, what do you need?
Based on the logo on your shirt, the thing that I'm going to request is the P550 microarchitecture optimizations in GCC and LLVM. There's 400, there's 600, there's no 550, and I've got a bunch of P550 boards. I would love to make them faster.
So I can, the LVM parts.
That's my quick answer.
we can definitely think offline on the LVM parts.
For sure, yeah, no, it's all
GCC
good.
part, my colleagues probably knows better, but yeah, noted.
It's all good.
Yeah, and just like any general directions, like we might miss because we kind of crunching the performance every day, but I'm worried about we crunching the wrong directions.
No, I think you're doing great. I think we're starting to get to the point where we're going to need to have feedback loops between the developers and LLVM to talk about things like auto vectorization. A lot of that is, and I'm not trying to throw shade, a lot of that is happening inside of the circles of the processor companies and the compiler organizations making it, not necessarily bringing in the information from the end users and what we're seeing. So it's just a matter of like trying to find an excellent corpus of software to bring in to help you understand where the bugs and the deficiencies are in that. And helping you figure out what that is. Like, I think that's the big one.
Yeah, the auto vectorizer I think is a good point because it's a huge works, and as you say, sometimes we might only have the feedbacks from our communities, and it certainly doesn't help that our issue trackers now is at over 10,000. So it's really hard to sort it out, and so yeah, I think it's more like maybe a problem of the LVN LVN like bug reporting process, but we definitely need a better reporting mechanisms.
Yeah, we're out of time, but the other quick answer I have is the FFmpeg team did a fantastic thing about 6 months ago, where in order to improve the performance of FFmpeg, they need people who understand deep-level assembly coding. And there's a small handful of people who know how to do that. So they spent the time to put together an entire self-paced learning GitHub repo on how to write SIMD optimizations in assembly for FFmpeg. Having something like that on how to onboard people into contributing to LLVM would be huge.
yeah, that is also one of the items on our backlog of the entire communities, because the truth is our documentation is terrible, and there's multiple attempts for tutorials in the past gathering, but yeah.
As the vice chair of the documentation SIG of RISC-V, I feel your pain.
Thank you.
So very, very briefly, from the HPC side, Flang, more mature, more development on Flang. It's doing some great progress, but we really work on there is always very much appreciated.
Thank you.
All right. Well, with that, the keynotes are going to start here pretty soon. I'd like to thank Google again and all of you for participating. As I think we're all saying, there's a lot of work to be done. Building the community, supporting each other is the best way we can continue to do that. So thanks again to Google, and thank you for coming, and we look forward to seeing you for the rest of the day. Thank you.
Thanks,
Ambassadors.